So, welcome back, dear friends. We will see now reaction of metals with chlorine. Before that, we discuss our reaction of metal, that is displacement reaction. More reactive, it can displace less reactive metal from its salt solution. Okay, and whatever less reactive metal get deposited as a pure metal. So, we will see our next reaction of metals with chlorine. So, basically, metals gives a metallic chlorides with chlorine. In such reactions, metal atoms attain a positive charge to become cations, while chlorine atom become anions after attaining a negative charge. So we will see examples. So as you know, metals are electropositive always, and non-metals are electronegative. So we will see first our first reaction of sodium with chlorine. Reaction of sodium with chlorine. So basically sodium reacts readily with chlorine to form a rock salt. So rock salt is what? Your NaCl. So here Na, your metal solid, plus Cl2 gaseous, that gives what? So for balancing the reaction to Na solid, so it will balance. So basically it will what is the another name of this? Rock salt. Okay, as you know, our general common name sodium chloride, but this they will ask what is the common, very common name of this rock salt. So see our second reaction of calcium with chlorine. Reaction of reaction of calcium with chlorine. So calcium reacts vigorously with chlorine to obtain a calcium chloride. So this reaction here, calcium solid plus Cl2 in gaseous. Always chlorine is in gaseous form. So that gives out CaCl2 solid. That is your calcium chloride. So like that reaction can happen. So metal chlorides are usually ionic solids and they conduct electricity when in solution or in molten state. Thus, the metal chlorides act as the electrolytes. So these are non-volatile and have a high melting and boiling point. So basically, very much important properties of this our metal halides, or we can say metal chlorides. They are non-volatile and have high melting and boiling point. So whatever our next reaction we will see, we are moving towards next reaction. Reaction of metals with hydrogen. What? Hydrogen. So most of the metals do not combine with hydrogen, and only a few reactive metals such as sodium, potassium, calcium, and magnesium form respective metal hydrides. So what they are forming? Respective metal hydrides they are forming. So hydrogen like metals have the tendency to lose electrons. So normally hydrogen atom does not accept the electrons given by the metal atom to form compounds. So here see a few examples, they can form metal hydrides. So we can see first example. So after combining metals with hydrogen, we call it as what? Metal hydrides. So see here first example, when your sodium solid, it reacts with H2 gaseous hydrogen, that is what? Hydrogen. So you will get NaH. NaH. For balancing the reactions, what you will get here? Balance reaction, balance. So sodium hydride, you will get sodium hydride, Na plus and H minus here. So second, suppose we will calcium plus H2 gaseous. So what you will get? CaH2. So calcium hydride. So this calcium hydride is it is also called as hydrolith. Common name of this hydrolith. So these are our reactions. We saw different reactions of metals. In that, metal plus oxygen, metal oxide, then metal plus water. We done reaction. Then metal plus dilute acids, mineral acids with strong acid, weak acid. We saw Then we saw on the basis of reactivity series. So in that we saw on the basis of reactive series, more reactive metal displaces less reactive metal, and less reactive metal gets deposited as a pure metal. And we discuss here reaction of metal with chlorine, now reaction of metal with hydrogen. So these are reactions are over. So here now it's time, now it's time to study uses of metals. So what here, uses of metals. So we can apply this uses of metals. So in uses of metals, very general uses here metals. So basically first we will see here first metals in biological processes, metals in biological processes. So as you know, in our blood also one metal present, that is hemoglobin. In hemoglobin, our metal, that is iron metal. So iron, that is Fe, is a constant of hemoglobin. So another examples also sodium, magnesium, potassium, calcium, etc. are essential metals required as a minerals in the living body. So here basically, as you know, iron, that is Fe, it is a constituent of what? It is a constituent of hemoglobin. Hemo Hemoglobin. And other elements also like sodium, magnesium, potassium, calcium. These are essential metals required to as a minerals in our living body. So metals in daily goods and machines also. So second, what will metals in daily goods and machines. So so many metals, copper, aluminum are used as for making electrical wires and cables. So so many uses are there of metals for joining railway tracks. Okay, it's for making engine parts. So so many examples here. Next, in metal in accessories. So here also metals in accessories also, metals in accessories. So as you know, gold, silver, platinum are used to make jewelries. So metals in health equipment also, mercury is used as thermometers. Yeah, our spagmo nanometers and barometers also, mercury is used. So metals in space projects also. So fourth, what we saw, metals in health health equipments, and we can say instruments. So metals in space projects also, space projects. So sodium, titanium, zirconium are used in atomic space projects. In that which example, sodium, titanium, then zirconium having symbol Zr are used in atomic space projects. So metal as a nuclear fuel also. So see, very much metals are important. Metals as nuclear fuel. So in that examples, uranium, neptunium, etc. are used as a nuclear fuel in reactors or in weapons. So very much important. So from that metals we are producing generating electricity also. So say seventh one, metals in economy. So over the period of time, coin has been used as a monetary transaction. That is very much important. Your coinage metals. So that is group 11 metals we saw already. That is gold, your then silver, copper, etc. have been used for making coins. Therefore, these are also termed as a coinage metals. So see, these are examples of coinage metal. Our group 11 metals. It is very much important. Okay, so these are our uses. So whatever next part we will discuss in next lecture. Thank you.